Hello class. Today let us derive the identity divergence of curl of tensor A is equal to curl of divergence of the tensor transpose. Right? Okay. What is capital A here? Capital A is the second order tensor. Second order tensor. So whenever it is a second order tensor, what about the curl of that? The curl of A is also a second order tensor. Right? Then what is divergence of this? So div of curly. Curly is second order tensor. So divergence of this is 1 less than that. So is a first order tensor, and first order tensor is nothing but a vector. It's a vector. So vector, no, so one free suffix should come. Take LHS. LHS. So write LHS. Okay. Very simple. Okay. Now it's a vector, no. One free suffix will come. We'll take the free suffix as I. We'll take the free suffix as I. Now we'll use components. We'll write in terms of components. Now that's nothing but I want divergence is nothing but differentiation. So first let me write that's nothing but curl A is what? The second order tensor, right? So for this, no, two suffixes must come. So one has to be I. Next one, we'll take it as J, right? And divergence here, so it is differentiation, comma, right? And I component over there, so this has to be J. That is now. So now I want curl A. Curl A is a second order tensor having two components ij. Now let me write this in terms of epsilon. So epsilon. So first one, the first one I here will come I, right? The remaining two suffixes have to be dummy, so we can choose any one. So here we'll take it as M and N. And for the tensor A, the components are IA, IJ, right? So now we'll take A. Now I have to choose the suffixes now. So I have to take J there according to the definition of curl. So J. And if I take Mn for epsilon, the second and third, suffixes, here it has to be the reverse. That is N, comma, M. This is nothing but curl of A. Curl of A, Ij components. So look at I. So here is I and here is J. Right? If it is Mn here, it has to be the reverse N, comma, M. That is the definition of curl A in terms of notations. Right? Okay. And close the bracket. Comma J as it is. Comma J as it is. Now that is epsilon Imn as it is. That is nothing to do with the differentiation. So that is outside, it's a scalar. So outside. And the remaining is Jn, comma, M and G. Right? Okay. Next step. That is epsilon Imn. Okay. So A, Jn as it is. Right? Now, first differentiation with respect to M, then J. Or I can reverse this J, M. They are same, no? First you differentiate with respect to M and then with respect to J, or first you differentiate with respect to J and then M, both are same, right? So I can reverse that, so both are same. So now that is equal to epsilon Imn. Remember in the RHS I want transpose, right? Now what will I do? So what do I do is, we'll combine first, okay? So AJN as it is, comma J. Now I'll take M outside, comma M outside. That is equal to epsilon Imn Now I'll reverse. So when I'm reversing, I should remember, I should take transpose, right? Let me reverse that. So it is A, right? Nj, I'm reversing, okay? Comma J, comma N. So I'm, see, here it was Jn, I just reversed it as Nj. So, and there is comma also, you should remember that. So that is epsilon Imn, epsilon Imn. This is, there is comma here, right? So that's nothing but divergence, divergence because J is dummy there. So divergence of which tensor? A or A transpose? If I take A, then the previous step. But here I've reversed it, Nj. Remember, I've interchanged rows and columns. So it is divergence A transpose. Divergence A transpose, right? Which component? It is the nth component. Gamma n as it is. Right? Now watch. See, you have epsilon I mn, mn, and you have some, vector here, divergence of a second order tensor is a vector here, right? And it is the reverse there. Is it not curl definition? So curl divergence A transpose, right? Which component? The whole thing, which component? It is I component because there is I, right? So therefore, this is nothing but our RHS. This is nothing but our RHS. So we have proved the identity, very, very important identity. When you interchange dive and curl, A will become A transpose in the RHS. Right? So we shall stop now. We shall prove one more identity in the next class.